Welcome, everyone, to our second xeoMeetup edition. And we are very happy to have you all here. For those of you who joined for the first time, we've started this series to have a more direct exchange with you and to brief you on things that we are currently working on, and some also older things, let's say well forgotten things, part of the xeokit universe. And yeah, some practicalities before we start. We would use, so please use the chat to share with us your thoughts and questions. So we are always happy to hear. And then you can also unmute. We would have a presentation part at the beginning. We have 4 topics for you today, and then we'll make sure that there is also space for casual exchange and live Q&A session. And yeah, probably you've already seen the agenda for today, but just briefly, we'll start with more technical WebGL related topics with Lindsay and Michał, discussing fundamental topics of data textures and how we utilize them in xeokit, starting with Lindsay. Then Michał would show one relatively new feature with the SectionCaps, where we even did some improvements lately, but it's from this year feature. And then we move on to a more BIM related topic, where we're going to talk about exchanging data between different softwares, and it's like a special development of Wojtek, this minimalistic .bim file format and how it integrates with xeokit. And last but not least, we have Marcin with a FastNavPlugin implementation, and this evergreen for performance for navigating large and heavy models. So I guess we have covered the more formal part at the beginning. We keep it casual, as I mentioned. So whenever there's anything, please let us know in the chat. And without taking too much time, I would pass on to Lindsay for the data textures. So Lindsay, stage is yours.
Hi, thanks, Stephen. I'm just going to start by sharing my screen. I've got some slides here. Okay, share. So, can you see my screen? Yes.
Yes.
So today I'm just going to talk about the way that we represent 3D models in memory using xeokit. And we have 2 ways to do this. We store models using the traditional techniques of vertex buffer objects, and we also use a lesser known technique where we store them in data textures. And I'm just going to quickly show you the techniques behind that we use in xeokit. And first of all, just in case, I'll just define what WebGL is. WebGL is the graphics API that we build xeokit on top of. It's an HTML5 API that exposes underlying OpenGL libraries to JavaScript developers so that they can program graphics applications on WebGL. And we use this in xeokit. How it works, within JavaScript, you basically get a context from your HTML canvas, and then through that context, you can access WebGL, and you typically upload data to WebGL in the form of buffers and shaders, and then you tell WebGL to use those shaders to draw those buffers, and it renders the scene. And so on the CPU side, you're preparing your geometry and buffers, you're creating and uploading your shaders, you're uploading any state that the shaders need, and then you're telling WebGL to just draw. And the GPU responsibilities are to run your custom shaders over your buffers to rasterize those triangles to the screen. VBOs, vertex buffer objects. These are fundamental part of WebGL, and they're basically just arrays in GPU memory that contain things like your vertex attributes. And once uploaded, you bind them and tell your shader to draw them. How they work? Yep, there we go. Using WebGL, we bind the buffer, load the data into it, enable a pointer for the shader to find it, and yeah, that's how you integrate it. Data textures, an alternative technique. More flexible, not quite as performant, but more flexible. So basically it's a texture containing lots of numbers, and into that texture we pack things like vertex attributes here and materials. But we can also pack anything we like into a data texture, and as long as you've got the code to parse it in the shader, you can pack strings and structures and objects and whatever you like. But we use it to encode geometry, but also lookup tables that enable meshes to reuse portions of that geometry. And another distinguishing factor, thing about data textures is that you can randomly access them from within the shader. So, yep, as I described before, we can pack numbers into a data texture and then fetch anything we like from wherever we like in the texture using a textful fetch. So data textures give us the ability to randomly access a buffer of data, whereas a vertex buffer object is an array that your GPU, your WebGL shader is kind of fixed in how it can iterate that array. It's sort of, it can only sort of iterate one primitive at a time, and the shader only knows the primitive that it's currently rendering. It's sort of stuck in that iteration. With a data texture, the shader can just, you know, if it can just access anywhere it likes into the data texture. And I'll show you here the key differences. So with vertex buffer objects, yep, they're very fast because they fit with the way that the GPU, the WebGL program iterates over the buffer. So it's the optimal way. But data textures, even though they're a bit slower because you're actually doing a texture sample, they don't have the same kind of size constraints that vertex buffer objects do, and yeah, like I said, you can, as long as you know where the thing is in the texture that you want, like the color or the matrix or something, then you can just sample it. And you can pack lots of different types of data into the same data texture. And now we're going to look at how does xeokit pack geometry data into a data texture. Here's the nuts and bolts. The goal here is to go for the smallest memory footprint we can get. We want to do lots of reusing of things. And so within xeokit, we store all our vertex data into one set of like atlas textures, concatenating all the vertex data together into the same textures. And then, yep. And then we have another data texture, which is a lookup table, where for each primitive index, the texture contains the index of the mesh that vertex or primitive belongs to. And then using that mesh index, we can look up the attributes of the mesh for the vertex that we're currently rendering in the vertex shader. And we can get things like the portions of the vertex arrays that mesh uses for its geometry. And so meshes can share portions of these arrays to effectively perform instancing. So here we are looking at the vertex shader, a sort of simplified representation of a vertex shader used in xeokit. The first thing we do is using the WebGL built-in variable vertex ID, which tells you the index of the vertex that the vertex shader is processing. We derive the primitive index, in this case, assuming that we're rendering triangles, and then using from this primitive to mesh data texture lookup texture, we can get the index of the mesh that the primitive belongs to, and then from there get the portion of the vertex arrays that belong to that mesh, And then again, using the GL vertex ID, we can find the exact position that this vertex shader is processing, and then just output the transformed vertex through the built-in vertex shader GL position variable. So that's essentially how we use data textures in the shader. And it's just another look at that. From the vertex ID, we get primitive ID, from primitive ID, mesh index, from mesh index, mesh ranges, and then we get position, and then we output that, all resolved inside the vertex shader. And that's pretty much another look at the way we do that. So if two meshes share the identical geometry, they share the same ranges within those vertex positions and normals and UV arrays. And for that, we get a much lower memory footprint, and we try to have as few data textures as possible to make things batch friendly and reduce the number of draw calls. A benefit of this compactness is, of course, a smaller payload to load into the viewer, smaller amount of data to transfer over the network. And also, because there's less memory in, less memory used in GPU memory, and also that when we update the state of an object, like its color, there's basically just less data to change within GPU memory. Compared to VBOs where we would do batching. I won't go into that, but one of the short answers is just lower bandwidth, less files, less use of memory, and less things to dynamically update within that GPU memory, so data textures can make changing the visual state of objects faster. xeokit's draw loop. We do as few draw calls as possible, and so in this slide I'm just showing how we might draw in primitives, and then with data textures we would then need to load a primitive, the mesh lookup table that contains n divided by 3 items, so that there's an entry for each triangle that's being rendered. So there's a summary of the packing format. I will not read this slide out, I'm conscious of time, and a live example. So this shows how we can use data textures in xeokit. They're actually enabled by default, but I'm showing here how you might manually enable them. So there's a live demo there of Halter Tower building, and yep, and my conclusion slide. These data textures are based on contributions made to xeokit by Tony Marty and Trivia, working for Trivia, and he created the first prototypes of data textures, which we then integrated into xeokit. And the first link is Tony's presentation of that at the Kronos meetup. Yep, and so you can find more about data textures in our blog. There's an article in there and a live demo. We've got lots of live demos of data textures in xeokit, where what I've actually got here is low-level tests. Oh no, okay, sorry, I'm getting lost. I'm going to wrap it up. Thanks, everybody.
Yeah, thank you, Lindsay. I think, yeah, we have also the link of the presentation to share with everyone the slides, so you can also more easily follow. So yeah, it's yeah, a bigger topic. This was let's say just a quick fly through.
Yeah.
Yeah. To see if your guys interested, we can always organize a deeper dive sessions or anything like that. So yeah, feel free to reach out. And then I guess we are then ready to move on with our next topic by Michał, SectionCaps, or how you can apply different materials to cross sections in the 3D model. So, Michał, stage is yours.
Thank you, Dian. Okay, so today I'm going to demonstrate how the SectionCaps feature works with xeokit, and the demonstration is based on the recent release of xeokit, which has been released today. SectionCaps feature has been present in xeokit for some time now, but it received a couple of updates recently, some accuracy adjustments. So if you wanted to give it a try, I would recommend using the latest version of xeokit to do that. And before I move on to examples, just wanted to quickly sketch the interface that SectionCaps feature uses, which is based on a single scene model entity property that is assigned a material. And currently, the requirement is for the viewer instance to be instantiated with the readable geometry enabled flag set to true. I will come back to this at the end, but for the time being, this is the only interface the examples I will present rely on to communicate with xeokit to achieve the effect. Okay, so here we see a very basic example. This is a regular cube, 6 by 6 faces, and I guess many of you will be familiar with the section plane feature, which is related to SectionCaps, but I will quickly describe it. So we have section plane is this plane that sort of visually cuts off one side of or part of the scene models that are on one side of the plane, and all that's left is everything on the other side of the plane. So if we rotate and translate the section plane around, you can see how some parts of this mesh get removed visually. And with section plane, by default, what we get is this kind of hole inside a mesh that we can see through and see some other meshes that are inside it, or see its internal walls, so to speak. And with SectionCaps feature now, we have a way to kind of close this gap with a mesh, with another mesh that gives kind of a feeling of how the kind of part looks like, sort of. And in case of a single entity, this is not really that helpful. But I'm just showing here this menu just kind of shortcuts to assigning this cap material property that I mentioned before. It assigns the menu assigns the cap material property to a material that you can see in the caption below. So these are really simple instances of the font material with different colors, and that's how the look of it changes. One additional, or rather, because the cap material can be assigned any font material, we can also use a material that uses a texture instead of a flat color. You can see the definition here in this pop-up. So that's a font material that uses a diffuse map, which is a texture pointing to a certain URL. And if we use a material like that, you can see that the section cap is actually this mesh that is created in place of a cross section is rendered with the surface. And on top of it, you can see that the texture is kind of anchored to position of a section plane. If I move the section plane around, the the texture would move as well. And because it kind of repeats infinitely, then we have this effect of filling the whole this whole space with this texture that is anchored to the position. And besides anchoring to the position, the section plane rotation also affects alignment of the texture. This could be useful in some cases. It's only a visual cue, sort of, but if someone needed it, they can manipulate the section plane directly to affect how the texture kind of is laid out on in the section cap. Now I'll move on to slightly more complex example. So here is a couple of meshes, and if I turn on the section plane again, let me kind of put it into some order. Okay. Now, what this example demonstrates is that we can assign different cap materials to different meshes, to different models, basically, or rather entities. So you can see how each of these entities receives a different cap material, and then their holes are kind of filled by this surface. If I assign a null as a cap material, I reset it back. So I reset the entity back to its default state, which is not using section cap at all. So as if only section plane cuts through it. So this is a slightly more complex example. And then we have another example which shows, I will turn on the topology display so we can see what's there. This is a single mesh combined of multiple geometries that kind of form those embedded shapes within it. You can see that there are some spheres and then spheres within spheres and so on. And without using section caps, we can see through it as we would before the section cap feature introduction. But now if I apply a section cap to this mesh, what we see is that the algorithm kind of understands what meshes form a hole inside the section, the cross section, and which meshes form another layer sort of those parts that should be filled in with the section cap surface. So if I move this section plane, you can see how different parts of this model are being cut through. And yes, we can also apply a texture here, and the same principle follows, that the origin of the texture space is anchored to the origin of the section plane and the rotation as well. Right, and the final example that I'm going to present is a familiar duplex model. This is more real-world example, and before without adding any section caps to the model, that's kind of what we see if we apply in a section plane. We see through those walls, through floors. This is as if, you know, this section plane cut off the part of the model. Now, if we can apply a cap material to all the entities, which does this context menu. Here it's a shortcut that goes through every entity and applies the same cap material to all of them. So we can see how now those voids are now filled with a color. course, we can change individual materials as cap materials as we see fit. So you could imagine that a real world example would use this one. A real world example would use maybe some hatching patterns that are used in engineering applications based on a texture. So we could apply this texture to all of the entities, and then you see how it's visible on all of them. Yeah, so I guess this brings us to this point. So if you download this latest release of xeokit SDK, you'll have those examples available, which are also available on our website. There are a couple of examples that use SectionCaps to demonstrate this feature in how it works. So feel free to play with it, to investigate, and to experiment. Yes, and to recap the whole presentation one more time, the interface to use this feature is through the cap material property assignment to an instance of a material, for instance, font material. And the current requirement is to use this flag while instantiating a viewer object set to true. We could in the future we could relax this requirement to not be required basically to use the cap material feature, but for now this is necessary to use. It comes at the small memory footprint cost for geometries to be retained by the viewer to make cap material algorithm possible to calculate those meshes. So yeah, that would be all from me. Thank you.
Thank you, Michał. Yeah, very interesting examples and very nice shapes. A bit like 3D art. Really nice to see. So yeah, these examples are also available through xeokit.io. So you don't need to go through GitHub or anything like that. But of course, on xeokit.io, they are hosted from GitHub. So yeah, these are the proper links. So yeah, I will take a look at the question in a minute. But before that, I would hand over to Marcin. We had some hiccups with Cloudflare, so not sure exactly. Oh no, sorry, I messed up a bit the order. Of course, it's not Marcin, it's Wojtek with the third topic of today with the dotbim format and how you can use it for exchanging data between different softwares and how it integrates with xeokit. So yeah, Wojtek, stage is yours. Thank you.
Okay, thank you, Dian. Can you see my screen?
Yes.
Okay.
Yes.
Okay. So let's start this presentation. So first, I will explain what dotbim is and why it was created at first place, and then I will go through the dotbim schema. Then I will go to xeokit integration of dotbim files and will present some quick comparison between xkt files and dotbim files. So to answer the question why it was created, so a while ago I was working on some BIM application, and at some point I wanted to create some exporter. I wanted to export some geometry and metadata from my application. And at some point, I wanted to make it possible to import some geometry and metadata to my application. So while doing that, I realized that creating exporters and importers it's quite difficult. It's a tedious work to do. So one thing that I've learned back then was that existing BIM file formats and generally 3D file formats are pretty complex. So I've spent a lot of time to read quite big documentations to understand all the rules behind different file formats. And then I had to check tons of different edge cases to make sure that my importers correctly import geometry and metadata. And then because of this complexity, because there are so many rules behind these file formats, then each software has its own interpretation of what is how to store these geometries. So, for instance, to test the importers, I have to export from different software. From various software, I have to export basically multiple different files to make sure that I can import it. At the same thing with the export. So once I added the export, I have to try to import it to some other different software. And for some software, my export was working, for others not. So for some of these exporters and importers, I was using the external libraries to make it a bit easier. But then I've learned that I still need a lot of time to understand the rules behind these formats to make it working. And because I was using then the external libraries, so some of these libraries have some limitations regarding what is possible, and some libraries just support only some parts of different file format. And then there was some other aspects like licenses. Sometimes were not so compatible with my software. And then even after that, for some file formats, I realized that, okay, I have the export of this file format or import, but only of this one specific version of this single file format. So for instance, I support the import of the version 1.4, but it turns out that the version 1.5 is a bit different. So I either have to accept this limitation, or I have to yet write more code to support various different versions. So it was really confusing to me that it is so difficult, especially because with document creation, here there are so many different document markup languages that I have to pick what I prefer. So, for instance, there is a LaTeX, which is quite complex and has a lot of different rules, but lets you create really sophisticated and huge documents. But on the other hand, you have a Markdown, which is extremely minimalistic, and it has only few rules to follow. So I could learn the whole schema of the Markdown like in one day and create some simple documents with it. So I realized that I would love to have something like this, but generally for BIM industry. So that's why the dotbim was created, to have as simple as possible geometry and metadata file format for BIM industry. How the schema looks. So in dotbim, we save all the geometries as meshes, and then we define the elements on the scene. So all the geometries are meshes, so they are saved as a points, and then you save the indices that defines the triangles. And once you have these geometries saved, then you can define the scene elements. So you specify that, okay, this specific element is represented by this mesh, and then you specify where it is on the scene. So you specify the position, the rotation of this element. Each element has its own unique identifier, and it has its own type, which you define. So it can be whatever you like. Here it's furnishing element, but it can be beam, column, wall, or however you name it. So there is some kind of classification. And then you specify the color of the element, and you attach some metadata, which is this simple dictionary. Here in this example, there is a dictionary with just one key value pair, which is this price. And here is the result of this file. So you have this teapot, which is represented by a mesh. You can see it's classified here as a furnishing element, and if you click on this teapot, there you have this property set which shows you the price, like in this example. But it works also for much more complex models. Like here, there is a model from Marcin who created this model in a Grasshopper, and with dotbim plugin, he was able to export it from Grasshopper to dotbim. So he saved all these geometries and metadata. So each element in this model has its own metadata saved there in dotbim. Going next to the integration. So if you'd like to check the integration examples, check out the xeokit website. And once you go to the xeokit examples, click the viewing building models, you will find there the whole chapter, which is called dotbim, with various different models loaded to the xeokit scene. Here is one of such models. So this model was created by Robert, who exported this house from Blender to dotbim. And then I was able to load it into xeokit with this dotbim loader plugin. If you are already familiar with loader plugins that we have in xeokit, it is really similar to other loader plugins that we have. So as you can see, it's just a few lines of code to load the whole file into the scene. To answer the question when it might be helpful for you. So for instance, if you have some BIM application, it might be your BIM application, or maybe there is some script that creates some geometry and metadata, or maybe there is some famous existing BIM application that you'd like to integrate with xeokit. So this is one of the methods how to do it. So you can either write your own exporter, which should be relatively simple to do, or you can use the existing exporters if there are, because there are many already. There are some connectors for some of the BIM applications that let you create the dotbim files. So for instance, there is a connector for ArchiCAD maintained by BIMDots company. So you can using this plugin, you can directly export dotbim file from it, and then with the xeokit loader, you can directly load it into the xeokit scene. So it's really simple, and it doesn't require any kind of conversion process to load such geometry and metadata this way. It also lets you create your own exporters the way you want it to maintain, and the way you want to describe the scene, because of how simple it is to create export for dotbim. To compare the xkt and dotbim file formats, so maybe some of you are familiar already with the xkt file format. So it is, let's say, native xeokit file format. The difference is the xkt is a binary file format, where dotbim is a text file format. It is actually JSON structured in a specific way. They both stores the geometry and metadata, and the biggest difference is the focus. So in xkt, we focus on storing the data in a way that it will be it will have great performance. It will have a short loading time, and the file size will be really compact. While in dotbim, I don't care about so much about such aspects, but I care mostly about the simplicity. So in other words, it would be probably quite challenging to create your own xkt export or import. For dotbim, it would be extremely simple to do it, but then the files loaded may be not so fast while navigating, or maybe loading slower or something. So if you'd like to learn more about dotbim itself, check out the dotbim.net website, check out the repository on GitHub. And if you'd like to learn more about integration, check out the xeokit website to find all these examples. Thank you.
Thank you very much, Wojtek. Yeah, quite an interesting initiative. So we'd be happy to get your feedback here as well on the dotbim format, and what use cases you would find for it, and where you can imagine using it in your daily work. So yeah, with this, I would then hand over the word to Marcin. I see that we still have issues with Cloudflare. It's like half of the internet is down, even ChatGPT. So we'll have to improvise a bit with the last topic. But I'm sure, Marcin, you'll manage somehow.
Yes. All right.
Yeah,
so let
stage
me
is yours.
start. Let me share my screen. Yeah. So xeokit SDK FastNavPlugin. So this FastNavPlugin is a viewer plugin that makes interaction smoother with large models, complex models, by temporarily switching the viewer to faster, lower quality rendering mode whenever we interact with the model. So here we can see some of the configuration attributes which we can set. And you can read more on xeokit SDK API examples. So here most impactful for the performance is the scale canvas resolution and the scale canvas resolution factor. So this is the factor by which we scale canvas resolution when we interact. And also interesting one, which is the onMoved, the callback function, which is fired when we interact with the model, which returns the callback function to restore it to the previous state. So let me show you an example. So this example, it is also hosted on the StackBlitz. It should probably work with the little outage or with the, but anyways, let's open some model just to quickly show the capabilities of the viewer. So here on the right-hand side, we can adjust the values for the scaling and the delay after restore. So it is clearly visible that when I start to move, the model quality decreases and the frame rate is higher. And here, if I stop moving, we can see that the frame rate drops a little bit. So we have all of the edges visible, PBR and the SAW settings enabled. And while we interact with the model, scaling decreases and everything gets turned off. So you can open this example also and play with your model. The other thing is that all of the tips for the performance is available on our xeokit.io blog post. So here, if you search for performance tips, you can read all of the tips for the best to get the best performance using xeokit viewer. Yep. So with that, what I can show you the last is Baku Stadium, which is loaded to XeoVision portal. It is loaded from my machine because of the Cloudflare issue. But here we can see that I have enabled the FastNavPlugin here. So with the custom settings to hide the different kind of IFC types and to scale the resolution to 0.2. So if I start to interact with the model, the quality of the model decreases, and I can move around, and even with this huge complex model as Baku Stadium, it is possible to go through and show this big model. So yeah, please make use of FastNavPlugin. It is really helpful to use it. So yeah, that's it.
Thank you, Martin.
That's all from my side.
Just maybe as a reminder, the Baku Stadium was how much? It was like 2 gigabytes of model, right?
Yes, and after conversion to XKT, it's almost 250 megabytes.
Yeah.
So
nice. So around 90% compression rate. Great. And yeah, so exactly one of the evergreens with the FastNav plugin. And some new strategies, of course, with the blacklisting and whitelisting elements by type or some other criteria. So it allows for flexible optimization strategies, also from each application. So yeah, would be happy to get also your feedback on this one. And I see that we already have the first question in the chat that I would like to tackle. So just to open up the round of questions, Niklas, if you would like to just ask your question, you can unmute yourself, start the discussion.
Hey all.
Hi.
I was just wondering when I saw the section plane component or plugin, if it was possible to style the gray rectangle with the black border, or if we would need to fork the component or copy it over into our own code base and then adjust it afterwards.
So yeah.
Yeah. So maybe I'll answer to this question. So currently the xeokit SDK doesn't expose any controls about how this transformation gizmo look like. So you'd probably have to implement such a control yourself, but xeokit provides some components that could allow it to do so. If you wanted this control to look differently, one way to do this would be to not rely on the original control that's implemented by xeokit, but instead, because this control is a separate object than the section plane itself. Section plane is really a position and rotation at the moment, and this transform control is kind of reflects those coordinates and also controls them. But if we can manipulate the section plane programmatically. So here you can see I manipulate the position of the section plane. We don't see the control, but the section plane is still there. And then given the section plane, and if I created a kind of custom transfer control, which is exactly this transformation gizmo that you saw before, embedded in the section planes plugin. But if we create kind of our own transformation control and we connect it through handlers with our section plane through those callbacks, and if we also set its position and rotation to the section plane, so we make this connection between our custom transform control and the section plane. Now, if I work with this gizmo through these callbacks that you see here, they propagate whatever transformation I apply to the gizmo, they propagate it to the section plane. So section plane this way reflects the transformation that is applied. So you could imagine if on top of this transform control, because this rectangle that you mentioned, actually in our implementation is not directly part of this control. It is a part of a section planes plugin combined with this control. So you could have a different, you could wrap this transform control in your own implementation that would also add some kind of a plane or something else if you wanted to this control, and this way manipulate existing section planes without relying on the default control, right? So I hope.
Yeah, I think I got it. It actually looks quite doable.
Right. So yeah. So feel free to experiment with it. You could also directly fork it in your code, right? And change internals, but perhaps this wouldn't be that necessary. Maybe some wrapping abstraction could do the work that you need, could do the customization that you need, right?
Yeah. All right. Thanks.
Thanks.
Right. Thank you, Niklas. I also remember for the slicing tool that we have implemented in XeoVision a kind of a preview plane of where this would be applied. So maybe you can have also kind of inspiration from there too, if you like it.
Right. This transform control actually was meant as a kind of general transformation gizmo, so you could transform a model with it or whatever. Whenever transformation applies, this visualizes this coordinate system that can be moved around.
Yes, there was also this aspect that you can also move around, for example, markup to the markup if you've applied it on the scene, like some symbols or images and so on. So yeah, exactly, quite versatile and so many options to customize. So what other questions do you have, guys? I have quite a technical session today. I hope it wasn't too technical for you. We'd be happy also to get some feedback, on the topics that we pick for the meetups and the way how we organize it for the future. So yeah, please feel free to share with us. We'll send you some also feedback survey afterwards. And yeah, I guess we still have a couple of minutes left if anyone would like to stay and go deeper into any questions. And otherwise, I think that we can conclude the official part with the recording. And yeah, thank you very much for being with us today. And looking forward to see you next time, which would probably be in January. So in the meantime, also happy and relaxing holidays at the end of the year. It seems very far away, but yeah, looking ahead. So yeah, thank you very much, and we keep in touch. See you around.
Cheers.
Thank you.
Thank you. Bye.